Hi, this is Mr. Urrego, and we're gonna work on the right triangle trigonometry. Basically, this is for pre-calc, and we're gonna use the 30, 60, 90 degree triangle to find the basic trigonometric ratios for 30, 60, or for an acute angle. Basically, we're gonna start with the 30, 60, 90 triangle. What I have here is no memory. I have no memory. So basically, what I do is I make, or I find out the ratios or the sides using the triangle. Right now, I'm going to use an isosceles triangle. I'm sorry, an equilateral triangle with measures 1 on 1, equilateral, with sides equal to 1 unit. So therefore, I'm saying that this is equal to this equal to this. Okay. If this is an equilateral triangle, then the angles have to be the same. If the angles are the same, that means each angle is 60, right? Each angle is 60. Okay. Why am I using this? Because I'm looking for a 60-degree angle. Now, once I have that, what I do is basically, let me draw it again, kind of, and remember, this angle on the top is 60 degrees. So right now what I'm going to do is I'm going to make a perpendicular line. Okay, that perpendicular line is, remember, here this angle is 60. Okay, I draw a perpendicular line which is an angle bisector to that triangle. So now instead of 60, I have each of these angles equals to 30. Alright, and because this is a perpendicular line, this angle is 90. Alright, so that's what I'm using this triangle for. So now, if I remember, the sides are 1, 1, and the bottom is 1. Because, but this line is a perpendicular bisector, and its angle bisector is dividing the base into two equal parts. Okay? 2 equal parts. So that side equal to that side. If the whole thing is 1, then each little piece is going to be 1/2. Alright? So now I have that. Now what I'm going to do is I'm going to take this off, because now I don't need the other half of the triangle. I just need this side of the triangle. Now I have my 30, 60, 90 triangle. Okay, that's what I want to show you. All right, now I have this side which belongs to my hypotenuse. This is one leg. Now I need the other leg. Okay, I'm going to use the Pythagorean theorem to find the measure of this side. Let's name this side equals to x. So the Pythagorean theorem is a squared plus b squared equals c squared. Remember, your c is always your hypotenuse. Okay, so the other side is 1/2. Let's scroll over to the second power plus x to the second power equal to my hypotenuse, which is 1 to the second power. So it's going to be 1/4 plus x equals to 1 minus 1/4 x squared equals 3/4. I need the value of x, so I do square root, and I'm going to have that x equals square root of 3 over square root of 4, which is square root of 3 over 2. Okay, that's the value of x. So let me go back to it, and then this is square root of 3 over 2. So every time I have a 30, 60, 90 triangle, that leg, which in geometry is called the lone leg, this is the lone leg, and this, let me do that again. In geometry, this leg is called the long leg, and this leg over here, the 1/2, is equal to the short leg. Why? Because the long leg which is this, is opposite to the bigger angle, which is 60. the short leg is opposite to the small angle, which is 30. Okay, so that's how you know which one is the long leg and short leg. So those ratios will always work out. Okay, so if my hypotenuse is 1, then my short leg is 1/2, and my long leg is square root 3 over 2 times whatever is my hypotenuse. Here, the short leg is half of my hypotenuse. Alright, so I'm just going back to geometry. Okay, so now we have the 30, 60, 90. Let's erase a little bit. So, okay, now I erase, and I have my triangle here, the 30, 60, 90 on the left side. We know the dimension of this, 1, 3, square root 3 over 2, and 1/2. Now, the ratios, sine, cosine, tangent. Alright. Sine is equal to opposite side over hypotenuse. Okay. Cosine is adjacent side over hypotenuse. Okay, let's work on those right now. So if I'm gonna do, remember when we're doing trigonometric functions, we do sine, cosine of the acute angles. The acute angles, in this case the 30 or the 60, those are the acute angles of this triangle. So let's say I want to find sine of 30 degrees. So it's going to be opposite side over hypotenuse, opposite side. So I'm doing 30. This is 30. What's the opposite side? Across. That will be the opposite side. So I'm going to have 1/2. Opposite side will be 1/2 over hypotenuse. My hypotenuse is 1. 1/2 divided by 1 is 1/2. So sine of 30 is 1/2. Okay. Let's do cosine. Cosine of 30. Cosine of 30 is going to be, that's a 0 by the way. Cosine of 30 is going to be, again, this is my angle, 30-degree angles. Opposite would be across of it. That will be opposite. Adjacent is right next to the angle, so this is the adjacent side. So the adjacent will be square root 3 over 2. So my cosine is adjacent over hypotenuse. Adjacent, square root 3 over 2 over hypotenuse, in my case, is 1. So my answer is square root 3 over 2. So always, my sine of 30 will be 1/2. My cosine of 30 will be square root 3 over 2. That's always. If I want to do my other acute angle, which is going to be 60, so let's erase this 30. Now I erase the 30, but now the angle that I'm going to do is going to be 60. So is the opposite and adjacent going to be the same? No. Now this is my angle, so the adjacent is right next to the angle, so I'm going to erase this thing opposite, and now this side turns into my adjacent side. Okay, this now across from my angle is the opposite side, so in that case this is my opposite side. Alright, so the opposite and adjacent is according to your angle. So my sine of 60 is going to be opposite. Oh my god, this is horrible. Hold on, I don't know what's going on with me today. There we go, a little bit better. Sine of 60 is opposite, which is square root 3 over 2 over hypotenuse. How much is the hypotenuse? 1. My answer is square root 3 over 2. The cosine of 60 is equal to the adjacent 1/2 over hypotenuse, which is 1. Therefore, your cosine of 60 is equal to 1/2. Okay? Now, later on, we're going to talk about cofunctions. Sine of 60 is the same as cosine of 30, if you notice. And cosine of 60 is the same as sine of 30. Okay, those are called cofunctions. Sine of 60 is the same as cosine of 30. But later on we'll do those. Okay, not yet. I just want you to know how you get sine, cosine. Now let's work on the tangent. Okay, the tangent. Let's scroll down. Scroll down a little bit. I need to erase. So let's erase over here. My tangent. Now we have sine, cosine. The tangent is the ratio for tangent of an angle, and we just did 60, so let's do 60. Tangent is opposite over adjacent. So in this case, tangent of 60, opposite. What's opposite? So this is my angle 60. Opposite is going to be square root of 3 over 2. Over adjacent. Adjacent is 1/2. Now square root of 3 over 2 divided by 1/2, those two cancels, and your answer is square root of 3 only. Okay? Once you divide these two fractions, then the answer is going to be square root of 3. So sine, cosine, and tangent, those are three ratios. What else we have? We have, okay, so let's write the other three trigonometric ratios. In total, we have 6 trigonometric ratios. We have sine, we have cosine, we have tangent of any angle. So let's call the angle theta. Okay. Sine, we just did, that is the opposite side over hypotenuse. Okay. The cosine, we did, that is the adjacent side over the hypotenuse. The tangent is opposite side over adjacent side. But I just mentioned that there was another 3, in total there's 6 trigonometric ratios. Now the other 3 are the inverse of these 3. So I'm going to have secant, cosecant, oh my god, and cotangent. Those are the other 3. Okay? So secant, cosecant, and cotangent. The way that I teach this, or that I find out that is the easiest way how to remember those other 3, because these 3 are the ones that you always use. Okay? The one on the bottom, those 3, we don't normally use it on a regular day, but we need to know them as well. So these 3 are inverse to the 3 on the top. How do we know? There's one that is obvious, which is cotangent. That will be the inverse of the tangent. So that's kind of, straightforward. So cotangent, COT, of my angle. If I'm saying the inverse, it's just basically flip these two. Okay? So you're going to have adjacent over opposite. And that's how you write that ratio. Okay? So we have the cotangent already. Now we have secant and cosecant. How do we know which one is inverse to the other one? The way that I remember is the following. If you notice, on these two I have sine, which starts with the S, and cosine, which starts with the C. The other two also start with an S and with a C. So the way that I remember is that you always have the opposite letter, and that's going to be your inverse. What I mean is the following. Sine, I have an S here and I have a C here. So the opposite is not the S, it's the C. So I have here that the cosecant will be the inverse function to the sine. Therefore, it's going to be hypotenuse over opposite. And what I have left is only the secant. So my secant is the opposite of the cosine, and my secant, you write it as SEC, and it's going to be the opposite of that, which is hypotenuse over adjacent. Okay, so that's the only thing you have to do. So now let's do one more example, and we'll just use all this. So let's say that I have, what are we talking about, the 30, 60, 90. Yeah, let's talk about the 30, 60, 90. Okay, so I have 1, I have 1/2. Oh my god. I have the 1/2 right there, and I have square root 3 over 2 here, and I have that this is my 30-degree angle. So let's find everything from that 30-degree angle. So sine of 30. We said that sine is opposite of hypotenuse. Opposite of hypotenuse. Opposite of 30. Opposite is 1/2 over hypotenuse, which is 1. Okay? Anything divided by 1 is the same. Cosine of 30. We said that is going to be cosine. Let's see, what's cosine? Adjacent. Okay? So adjacent is this side. So it's going to be square root 3 over 2 over hypotenuse, which is 1. Anything divided by 1 is the same thing. Okay? Now, the third one, my tangent. So, tangent of 30 is, let's see, tangent is opposite over adjacent. Opposite over adjacent. So, opposite over adjacent. Tangent is opposite. Opposite over adjacent. So, when you divide this, and let's do it real quick over here. Okay, when you're doing dividing fractions, basically what you do is you flip the second fraction and then you multiply. You flip the second fraction. I'm flipping this, so it's going to be 2. Oh yes. I had to rationalize that. So I flip the second fraction. Okay, and then I just multiply straight across each other. So I'm going to have 2 over 2 square root of 3. Okay, if you notice in this case, that 2 and that 2 cancels out, and I'm going to have 1 over square root of 3. So that'll be my tangent. But if you remember, can we have a radical on the denominator? No. So I multiply by square root of 3, and that's going to give me square root of 3 on the top. And on the bottom is going to give me square root of 9. Okay? But square root of 3 and square root of 9 is equal to 3. So, that's my answer. Again, this is the same as this. These two are the same. The only reason I'm not putting my first answer is because I have a radical denominator, and you're not allowed to have that. That's why I rationalized my denominator. Okay, and we did that before, hopefully you remember. So again, this answer and this answer are the same, but this is the proper way of writing it. Tangent, let's go back. Tangent of 30 is going to be square root of 3 over 3. Okay, so now I have sine, cosine, and tangent. I need to erase, hold on. We said that from here, we said that the cosecant, we said that, let's say with black, cosecant is the inverse of the sine. What I'm saying inverse is the ratio is opposite to each other. That's what I mean by inverse. The ratios are the opposite to each other. So cosecant goes with sine, secant with cosine, cotangent with tangent. So let's do cosecant and sine. Cosecant and sine. So I have sine, okay, I have sine which is 1 over 2. So cosecant of 30 is flipping those two, which is going to be 2 over 1. Now, cosine and secant. So let's go cosine and secant. So let me do secant. Secant of 30. That's with the cosine. And the cosine is square root of 3 over 2. So if the cosine is square root 3 over 2, then my secant is 2 over square root 3. That would be my answer. But question is this proper? No. Therefore, I need to multiply times square root 3 on the top and the bottom to rationalize the denominator. So on my top, I'm going to have 2 square root 3, and on the bottom, square root 9, which is going to give me 3. Okay? Again, this is the answer, but is it proper? No. I need to get rid of that radical, and this is the way I get rid of the radical. Okay, so this first answer and this answer are the same, but in a proper way. Okay, so secant is 2 square root 3 over 3. Just quick, you never leave a radical on the denominator. Okay, you always have to rationalize it. Never leave a radical on the denominator. That would be a mistake. The last one, we did cosecant and secant. Now we need to go and do cotangent. And cotangent is opposite to tangent. So cotangent of 30 is opposite to this, right? So we'll have square root, hold on. It's opposite to that. Opposite. So the 3 is going to be at the top, square root 3 on the bottom. Here we go again. I have a radical in the denominator. That means square root 3, square root 3. So I'm going to have 3 square root 3 on the top, and on the bottom, square root 9. 3 square root 3, and square root 9 is 3. But what happened with this 3 and that 3? They cancel out. So my final answer is square root 3. If you need to write it as a ratio, then it's going to be over 1 if you want. Okay, so there you go, you have those. So now we have the 6 trigonometric ratios: sine, cosine, let me see, sine, cosine, tangent, cosecant, secant, cotangent, and remember, these 3 are opposite to the other 3, so basically you just need to remember the first 3. That's the first 3 you need to remember as a ratio. Okay, this first 3 ratios you remember, then hopefully you remember the S and the C, the opposite letter, and obviously tangent and cotangent, well, that's straightforward. Okay, I just did the 30, 60, 90. I'm gonna do another video, the 45, 45, and 90 triangle. Okay, which is basically the same thing. It's just to learn how to get those measures from the sides. That's what I'm looking for. Okay, I don't have memory to memorize that. If you do, well, memorize. If not, learn how to do the triangle and get the sides, the length of the sides, which is what we need to find either the opposite side or adjacent side, to do the whole thing. And we use the Pythagorean theorem to find the third side as well. Okay, so that was the 30, 60, 90 triangle. I'll do a second one for the 45, 45, 90. Bye-bye.